Okay, so here we're going to do 4j. We'll start with number 2. It's asking us to find the arc length of this, and here's the limits of integration given. So since the limits of integration are given in y's, I want to do dy integration. So since I want to do, and you know the formula for arc length is 1 plus the derivative, and I'm not going to put it in the letter in there, squared. So I want to have y's in here if I want to do dy integration. So that means I want to solve for x. So that means I'm going to take the square root, and since the y values are between 0 and 2, they're going to be positive. So I'm going to use just the positive square root on both sides. So the positive y plus 4 to the 3/2. Okay, that's the first step. So now let's go find dx over, dy. So I'm going to write the 2 down, bring the 3/2 down, y plus 4 to the 1/2. Again, the most mistakes are made in the derivative, so be really super careful. Carry the 2, write the 3/2 down so that you don't inadvertently flip a number. Okay, so that's going to be my derivative. So it's going to turn out to be 3 times that, right? So the arc length will be from 0 to 2, 1 plus, and I'm going to have 3 times the square root of y plus 4, and that all gets squared dy. So 1 plus, squaring each term, 9, and then the square root squared just gives me y plus 4 dy. So I'm going to multiply that out. So I get 9y plus 36, 0 to 2. So I've got like terms in here. So I've got 9y plus 37 dy. Okay, this only has 2 terms in it. So I'm going to think and evaluate if an easy u substitution would be appropriate. And it is. So u equal 9y plus 37. du is 9 dy. So 1/9 du is dy. So I'm going to say the square root of 1/9 du. So 1/9 du. And then the square root of u. And I'm going to go change the limits. So I'm going to put y equals 0 in. So I get 37. And I'm going to put y equal 2 in. So I get 18 plus 37. So 55. All right, so then I'm going to take the antiderivative, 2/3, u to the 3/2, 37 and 55, so 2 over 27, so 55 to the 3/2 minus 37 to the 3/2. Beautiful answer right there. Let me double check that's what I got. And it is. Okay, good. All right, so I'm going to continue on with number 3 and 4. So I'm on 4j, number 3, and then number 4. And I'm going to write them beside each other so you can kind of see they're similar, but they're different. So this one is e to the 3x, 2 plus e to the x dx. Okay. So what happens if I try letting u equal the denominator? So if I let u equal the denominator, then du gives me, the derivative of that is 0. The derivative of this gives me 2e to the 2x. That's not helpful. This e to the 2x is nothing like this e to the x, so that's not helpful. So let's not do that. So this is where you start to think about clever. So I like to think, what do I know? Do I know that, 4 plus u squared, 1 over that, does that equal anything? It does. This is my arctangent. So you get clever by thinking about what you know. So I'm going to say let u equal, well, let me just even first rewrite this. Let me get rid of this. So I'm going to rewrite this as 4 plus e to the x squared dx. And it's because I'm thinking of this arctangent thing, right? So I'm going to let u equal e to the x, du will e to the x dx. So I'm just going to even go a little bit further. So e to the x dx. This is a little bit challenging. So this e to the x dx comes out and du goes in its place. This e to the x goes in the place of here, so I get 4 plus u squared. This is my arctangent. A is 2, so I get 1/2 arctangent of u over 2, and then I put the x's back in. Okay, this one is not the same. It's completely different. If I let u equal the denominator, then I get du is e to the x dx. And that's not what I have up here, but it's a different dilemma than what I had over here, right? So this has more of them. This I had, when I tried to let u equal the denominator, I got too many and there weren't enough. You can never pull x's outside of an integral. So I'm thinking, let's break this guy up. So e to the 3x is the same as saying e to the x times e to the x times e to the x, right? Okay. So one of those e to the x's and the dx's has to come out in order to get the du in. The denominator is u, so now what am I going to do with those two things? E to the x times e to the x. This is the clever part. So you want to say u minus 2 is e to the x. So that will give me u minus 2 times itself twice, so u minus 2 squared. So now I'm looking at an integral that has only u. So you want to make sure you have only x here, and then you have only u. And then once you get to this only u step, I notice that I'm going to have to multiply it out. So I get u squared minus 4u plus 4 all over u. And then I notice I'm going to have to separate it around the addition and subtraction in the numerator. So u squared over u gives me u. Negative 4u over u gives me negative 4, and this gives me a 4 over a u. Now I take the integral, u squared over 2 minus 4u, and this you know is ln. Make sure you put the absolute value bars down, and then replace what the u is equal to. So I have 2 plus x squared over 2 minus 4, 2 plus I'm sorry, I said that wrong, 2 plus e to the x, and then plus 4 ln of 2 plus e to the x, plus c.